Welcome to the fifth session of the Unit 1 Frame of Reference prescribed by the Karnataka University, Dharwad for BSc first semester. I am Vasant S. Nayak from Government First Grade College, Kumta. In the previous four videos, I have explained you about Galilean transformation equations, variance and invariance of physical quantities under Galilean transformation equation in inertial frame of reference, and also we discussed about non-inertial frame of references, frictious force and Coriolis forces. Let us solve some of the problems. The first problem is calculate the frictious force and the total force acting on a freely falling body of mass 20 kg with reference to a frame moving with a downward acceleration of 10 meters per second square. Here I have to calculate the frictious force as well as the total force which is acting on a freely falling body of mass 20 kg. And here reference frame is moving with a downward acceleration of 10 meters per second square. That is with reference to a moving frame with a downward acceleration of 10 meters per second square. You know that Earth is considered to be inertial frame of reference and taking downward direction as a negative sign. Remember, take a negative sign at this point. This is the given quantity, mass is given 20 kg, acceleration A naught is given, is 10 meters per second square. Now this is the real weight we have to calculate. The real weight of the body is Fi is equals to m into g of the gravitational force acting on the body. This mass is 20 into 9.8 negative sign, that's equals to minus 196 Newton. So the negative sign indicates that weight is acting in the downward direction. Now, when the body is moving vertically downward, the frictious force acting on the mass during the downward direction. That is, now the object is in the moving frame and that moving frame is accelerating, and that accelerating frame produces the force. It's not a real one. That force is called frictious force or pseudo force. The expression for the frictious force F naught is equals to m into A naught. A naught is the acceleration of the frame of the reference. The mass 20 into minus 10 because downward direction is negative. So for 20 into minus 10, that gives the minus 200 Newton. And we have derived the expression for the force acting in the inertial frame of reference. S dash is F equals to Fi plus F naught. Otherwise, if we change the notation here the Fi is equals to F plus F naught. What is Fi here? Fi is the force in the accelerating frame, that's equals to F real force plus frictious force. Therefore, F is equals to Fi minus F naught. Therefore, total force in the accelerated frame is equals to Fi minus F naught. That is Fi real minus 196 minus 200 N. This is the frictious force. Therefore, minus 196 plus 200 is equals to 4 Newton. That's why here the frictious force is how much here? The frictious force is minus 200 Newton. What's the real force? Real force is minus 196 Newton, and the total force The accelerated frame is 4 Newton. To solve the second problem, it is calculate the frictious force and the total force acting on a freely falling body of mass 5 kg with reference to a frame moving with a upward acceleration of 10 meters per second square. Is the similar problem? It is similar to problem 1. Only thing is the frame moving with the upward acceleration. In the first problem, it is in the downward acceleration. To solve this problem, Earth is considered to be inertial frame of reference and to take upward direction as a positive. And in the given problem, mass is 5 kg, acceleration is 10 meters per second square. Actual weight of the body is m into g, that is 5 into minus 9.8 minus 49 Newton. Here the negative sign indicates that weight is acting in downward direction. Now, when the body is moving vertically upwards, the frictious force acting on the mass during the downward motion, that is F naught is equals to m into A naught. This is equals to 5 into 10. You have to take upward direction as a positive. Therefore, 5 into 10 is equals to 50 Newton. For total force in the accelerated frame is given by F is equals to Fi minus F naught, that's equals to minus 49 N minus 50. Therefore, the total is minus 99 Newton. Let us solve the third problem here. So the third problem, a frame S dash is moving with velocity 3I plus 5j meter per second relative to an inertial frame S. A particle is moving with the velocity t plus 3I plus 7j meter per second with reference to S. Find the acceleration of the particle in the frame S dash. The given problem, velocity of the particle in frame S is given by U equals to t plus 3 into I plus 7j, and velocity of the frame S dash relative to S is V equals to 3I plus 5j. According to Galilean transformation equation for velocity of the particle with respect to frame S dash is equals to U dash equals to U minus V. Here substitute the value of U and V. U is T plus 3I plus 7j minus 3I plus 5j, that's equals to Ti plus 2j per second. Acceleration of the particle in frame S dash is given by A is equals to, so du dash by dt, that's equals to du dash by dt dash. That is du dash by dt dash is equals to du dash by dt. If I have to differentiate Ti plus 2j with respect to time, here you get I is equals to meter per second square. That is, here y dash equals to y, z dash equals to z. According to Galilean transformation equation, if the particle is moving along the x-axis, and this is only the variable. That's why the differentiation of Ti plus 2j with respect to time is I meter per second square. The fourth problem, to solve this problem here, find out the frictious acceleration of the sun in a frame fixed with the earth and rotating about its axis. Distance of the sun from Earth is given by 1.5 into 10 raised to 13 centimeter. Here, according to rotation frame of reference, angular velocity is given by, we know that omega is equals to theta by time taken. Here theta is, so one revolution means 360 degree in one day, that is 24 hours, minute into second. Therefore, omega is equals to 2 pi divided by 24 into 60 into 60. You know the expression for fixed acceleration, that fixed acceleration of the sun is omega square into r, where r is given 1.5 into 10 raised to 13. Therefore, substitute the value of omega 2 pi 24 into 60 into 60, its square into r is 1.5 into 10 raised to 13. If you solve this equation, you get 7.8 into 10 raised to 4 centimeter square per second. So this is the fixed acceleration of the sun. Now this is the fifth problem. So in the problem, an observer S who lives on the x-axis sees a flash of red light at 1210 meter. Then after 4.96 microsecond, a flash of blue at x equals to 480 meter. Here you have to use subscripts R and B to label the coordinates of the events. These are for red, B for blue. What is the velocity relative to S of an observer S dash who records the events as occurring at the same place? Here, physically, what happens is that the observer sees the flash of red, then travels at velocity v such that he arrives just in time to see the flash of blue. Therefore, xr minus vtr is equals to xb minus v into tb. Therefore, here v is equals to xr minus xp, so divided by the tr minus tb. Here xr is 1210 minus xp is 480 divided by 0 minus 4.96 into 10 raised to minus 6 second is given 4.96 microsecond. That's equals to minus 1.47 into 10 raised to 8 meter per second. Thanks for watching. Best of luck.